You've probably heard it a million times. In the world of AI, bigger is always better. But what if that's not the whole story? What if a smaller, mid-tier AI could actually beat a top-tier giant? Well, today we're diving into some fascinating new work from Meta and Harvard that completely flips that idea on its head. So let's start with this puzzle, because it really challenges everything we thought we knew. How in the world did Claude Sonnet, which is a solid mid-tier model, manage to beat the much bigger, more powerful Claude Opus at a super complex coding task? On paper, that just shouldn't be possible. For years, the rule of thumb in AI has been pretty simple. Bigger equaled better. You throw more parameters, more power at a problem, you get better results. But what this new research is telling us is maybe not. It suggests that the system around the AI, the whole setup, is what really gives it the winning edge. Okay, so to really get how this upset happened, we first have to understand why real-world coding is such a nightmare for AI agents today.
Here's a good way to think about it. Imagine current AI agents are these brilliant surgeons, right? But they're also super forgetful. Now drop one into a huge hospital with no map, zero patient history, and just a basic toolkit. They might be amazing at one specific procedure, but they're going to get totally lost trying to manage a complex, multi-day operation. That's the problem.
And this is exactly where the new solution from Meta and Harvard comes into play. It's a new system called the Confucius Code Agent, and it's all powered by something they built called the Confucius SDK. And this quote right here is the key to everything. They didn't just wrap a fancy language model in a simple script and call it a day. No, they focused on building a really sophisticated support system, this scaffolding, and made that the main event, instead of just banking on the model's raw brain power. So, what's the secret sauce here? Well, it really boils down to three core ideas that create this much smarter system. And together, they give the AI agent a huge advantage when it's trying to navigate these messy coding projects. First up, you've got hierarchical memory. Think of this like a detective's case file. But it's only the summarized version, not the entire archive room. It intelligently boils down all the past steps and decisions, so the agent always has the most critical info right there, without drowning in all the noise. Next, there's persistent notes. This basically acts as a powerful long-term memory. The agent literally writes down what worked, what didn't, and what it learned. So the next time it faces a similar problem, it doesn't have to start from scratch. It actually learns from experience. And finally, modular tools. Going back to our surgeon analogy, this is like giving them a state-of-the-art operating room full of specialized equipment instead of just a basic first aid kit. The agent gets access to powerful, purpose-built tools, and, this is crucial, it knows how to use them really, really well. And get this, what's really wild is that they actually used an AI to help build the AI. They have this thing called a meta agent that automatically works behind the scenes, constantly fine-tuning the main agent's setup, testing it, and improving it. It's like having an automated pit crew. So the big question, does this smarter system actually work? Okay, let's get to the proof, because the numbers are where this whole story gets really interesting. All right, have a look at this table. These are the results from a super tough software engineering test. Now, what you really want to pay attention to is the comparison between those top two entries. Look at the model being used, and then look at the system it's running on. And this chart just says it all. This is that upset victory we were talking about. The mid-tier Sonnet model, when it's powered by that smart Confucius system, scored a 52.7%. That's actually higher than the top-tier Opus model, which was using a more standard, weaker system and only got 52.0%. The better system won. And the efficiency gains are just massive. Thanks to that smart, persistent note system, when the agent had access to its old notes, it used 11,000 times fewer tokens on average to solve the problem. That's a huge saving in both cost and computing power. This is also amazing. It proves that how an agent uses its tools can be almost as important as the brainpower of the agent itself. Just by giving it a better way to handle its tools, its success rate shot up by nearly 8 percentage points. That's huge. So what's the big takeaway from all this? Why does this matter so much? Well, this isn't just about some new coding agent. It points to a fundamental shift in how we should be thinking about building AI. What this shows us is that the race in AI isn't just about building bigger and bigger models. The architecture, the memory systems, the tools, that entire system surrounding the AI can actually be the thing that makes or breaks its success. And that's really the new paradigm here.
This research suggests that the next big breakthroughs might not come from building a bigger brain, but from building a smarter system to unlock the incredible potential of the AI models we already have. Which leaves us with a final thought to chew on. Maybe the future of AI won't be defined by the giants who can build the biggest models, but by the architects who can build the smartest systems around them.